Hello and welcome to WETO tutorials. Today we are talking about some smaller features, namely the light roof structure and how can we modify the layers, how can we manipulate, what kind of structure do we put onto the heavy framework. So here I have a list of layers which I want to construct onto the heavy roof framework, and I'm going to show you the standard one. You may already know that if you press the F9 button, you can generate the standard layer definition onto the roof, which consists of some insulation, the battens, and the basic roof tiles. Now we can always differentiate from the default layer distribution, and I will show you how exactly. Let's go into the profile editor, select our main profile, and here at the battens/roof assembly we can change the structure of the light roof frame. Here at the roof assembly we can open up a new window, and this is Viskon's new feature coming from the V17 in German and the V18 in other languages. So we are at the V18 and we have this new roof assembly editor. So here we have the basic layers and listed in this window, but it's totally different than my list. So let's see how can we change it to our liking. First, let's start by deleting all the layers. We don't need any of these. We will make ours. So we have an empty list, or almost an empty list, because the roof covering always stays here. You cannot delete this layer. You can change it though, so that it has other properties, but you cannot get rid of it. So we can disable the roof battens though, which I will do right now. So we have a clean sheet, and let's start by putting on the first layer, which is gonna be plasterboard having a 13mm thickness. So when you click on the add layer button, you immediately get a new roof layer, which is a basic boarding by standard. But let's change that to the plasterboard we want. We have intersection, which means that detects the rafters, and this will distribute throughout all the roof surface, which is different from the other ones like the insulation. The insulation gets distributed only the inside of the building, not on the overhang. The exposed is the exact inverse, which is only the overhang boarded. And the final one, the rough, is again the inside, but stretched out to the wall exteriors. So that's the difference between these intersections. For plasterboard, we need to choose the rough option. Surface type is also a similar question. We use the universal option here. The component type will be panel, And lastly, the material is gonna be, let's see, panels, plasterboard, right? Okay. Finally, you can see that our layer sits right now on top of the rafters, but I want the plasterboard to be located underneath the rafters. As you can see, we have plaster, on top of it an OSB. So this list basically goes from bottom to the top. And we have the heavy roof structure on top of the OSB. So let's change the place of our first roof layer by clicking on this bottom level. Right now, it intersects with the rafters, but with the distance option, we can change its place. First, let's change the thickness, which is gonna be 1.3 centimeters, and the distance is minus 1.3. Right. So we have this one. The width is 175 centimeters because this is how the plaster boards are manufactured in 125 width. But we also need to place an OSB layer on top of our plasterboard. So let's create the new layer. Oh, and I forgot that you can also rename these layers so that you know which layer you are correcting. Plasterboard. Then comes the OSB, which is rough. This is going to be the rough intersection. Universal surface, yes. And it's also a panel. The material is OSB. The width of each piece is 125 again. And now we need to define the placing. The thickness will be 1.2, as you can see here, 12 millimeters. We need to put down on the bottom level, put it down there. And now the distances. Of course, we insert a minus 1.2 centimeter. This is in the right place now. And going back to the plasterboard, we need to add another 1.2 centimeters, and that's how it's correct. Minus 1.3, which is the plasterboard thickness, and minus 1.2, which is the OSB. Okay, we are done with the layers underneath the rafters. Let's go one layer above, which is a heavy roof structure. I wrote 200 millimeters, which is 20 centimeter. We have a rafter dimension of 18 centimeters right now, but we can change this in the profile editor. We won't go back there. This is fine right now. We need to add the rock wool insulation between the rafters. So that's what we're gonna do next. Let's add a new layer. This is insulation, rock wool, something like that. This is gonna be the insulation intersection for now. Surface type is also insulation. Boarding, it's not gonna be boarding, it's gonna be a panel again. And the material is Where is it? Glass wool, rock wool. This one. Fine. We have the material and all sorts of parameters. We need to place in the right height. So again, let's put it on the bottom level. And all we need to do is increase the thickness to 18 centimeters so that it has the same height as the rafters. We can increase the width of the insulation blocks. Now I don't know the exact measurements for these. I stick with 125 centimeters for now. Okay. So what's next? We have another OSB panel on top of the rafters and the insulation. So we need another layer, another OSB. It's a 15 mil. The other one is a 12 mil. This will stay as determination. I know the translation is not perfect, but that's how you use it. We'll stick with universal surface type and panel as component type. We'll search for the OSB just as before. And lastly, we need the thickness, which is 1.5. And that's it. The place is correct, so we don't have to move it. Let's continue with battens. So it's a new one. Let's name it battens. This is also determination type, universal, and now the component type is battens. The difference between battens and counter battens is the orientation, vertically or horizontally, you can see. So it doesn't really matter which one you use, as long as you have the right orientation, what you want. Right now I want this one, this crossways battens. The cross section is 50 by 50 mils, so 5 centimeters by 5. Yes, sometimes does things like this one, the program, but don't worry, you just go back to the top level. It randomly sets the bottom level for new layers, but it's nothing unchangeable. We are currently intersecting with the OSB, which I forgot to set to 125. Back to top level, okay. We need to increase the height of the battens, so we type for distance a 1.5 centimeter value, so it sits right on top of the OSB layer. You can see that we are getting closer and closer to the roof covering, which we can increase the height of it, so it won't intersect with our other layers. Okay, continuing with our list is another rock wool layer, but first I'm gonna show you the distribution of the battens. So I wrote here a 595 millimeters distribution, which is 59.5 centimeters, and this is how you can manipulate the space between your battens. Okay, and now comes a new insulation layer, rock wool, surface type insulation, and panel as component type. And let's search again for the texture, rock wool. That's right. The thickness is 5 centimeters. The distance from the rafters is 1.5. Width 125. Go back to top level. Okay, that's right. Also, you can try doing a boarding if you want to leave space for the battens. Now you can choose battens also. You can stay with 58 centimeters width, and the partition distance is 5. As you can see, I am trying to leave space between the insulation blocks for the battens. Problem is that right now we don't have the tools for these kind of precise movements, but you can do something like this. That's why I usually use the panel, simply just the panel option, so it covers the full surface. Alright, let's continue with boarding. And you know the drill by now. Add a new layer, name it boarding, determination, because we want to locate in the full surface. Boarding, that's right. C24 is material, that's also right. The distance is gonna be 1.5 plus 5. So you don't even have to make the calculation in your head. You can just simply type in the equation and the program does it by itself. Okay, we have a 150 millimeter boarding. That's what I type here. All right. The next is an anti-condensation membrane. This membrane is not included in this list, but you can get creative and select the boarding, determination, universal. I give it a name, membrane. And as texture, we can use something like polystyrene or flock insulation material. I know it's not exactly the right choice, but that's what we can use right now. Okay, the thickness is 0.1 top level, and the distance is 1.5 plus 5 plus 2, I guess. I don't remember what was the boarding thickness. Yes, 2 centimeters. So the membrane is located on 8.5 centimeters from the rafters. And we can change the boarding. Yes, we can change the width to be even higher so that it's just a huge layer in one piece. Counter battens is the next one. So add a new layer. It's also determination, universal, and as component type it's gonna be counter battens. C24 is material, is okay. The height or the distance is 8.5, and we can choose for the battens to be based on the rafters, so every position is located on top of on a rafter. Okay, we have a cross section of 30 by 50, so 3 centimeters by 5 centimeters, and this layer is solely for ventilation. The final 2 layers can be modified here in the roof covering section. So now we arrived at the final touches. We can put back the roof battens by clicking on this create checkbox. The battens itself are 9 centimeters by 2 centimeters. And the distance will be, as it was, 1.5 plus 5 plus 2 plus 3. And we arrived on the top of the last counter batten layer. Okay, and to finish it all up, let's change the roof tiles thickness to 5 millimeters or 0.5 centimeters. That's right. So this is the overview of our finished light roof framework. If we click OK, we can apply the changes on this single roof, or we can save the entire definition as rough roof insulated, or if you change its name, test 1, save definition, and click OK. And this way you can agree the changes on this side, on the left side. You can also click transfer to transfer this roof assembly to the other side, or you can go into the roof assembly module on the right side, roof assembly again, and here open definition, and we have some already made definitions, but this is our newly made one. You can select it, click OK, and it immediately applies all the changes. OK, OK again, and the final OK. And the last step is to press F9 to create all these layers, and we can check the interior as well. If we disable the walls, that here is our plasterboard, the OSB layer, the rock wool insulation, and all other layers that we made. So that's how you create your own light roof layers. One last thing that you can change is the surface material of the roof covering. If you select it as a component, right click and set material color, you have lots of new roof covering materials. For example, I want to place a zinc roof tile on top of my house. That's how I can do that. Let's do it again on the other side. Okay, and if you want, you can simply just delete this top piece, and here you have a metal roof covering. So here you have it. I hope I could show you something new, and that you can make your work a little bit easier with these features. Thank you for watching. Don't forget to ask your questions in the comment section, and see you in the next one.